Hello everyone, and welcome to today's workshop, Marine Data for Sustainable Oceans for the Copernicus Marine Service. My name is Gail Enav-Sterbik, and I'm a training officer at Mercator Ocean International, and I'll be your host for today. As you know, we will have a two-day workshop, and today we will have an introductory session where we'll tell you almost everything about what the Copernicus Marine Service is about. So before we start, we are going to go through some house rules and guidelines to help you follow this workshop in the best possible way. So first, please do not use the chat that you see on your right-hand side for your questions. You can use it for small talk or to say hello to us. But if you have a more technical question or if you have any other question, we invite you to use the Q&A section on the website, so you will find it on the top bar of the page. And when you click on it, you will see an area dedicated to the Q&A, and that's where you can ask our speakers your questions today. And next to it, you will also find a survey about the workshop that you can answer at any time. Sorry. And yeah, speaking of our speakers today, so the agenda, we will have many presentations. So we will start after an introduction to the Copernicus Marine Service that I will do. We will start with a demonstration of the visualization tool MyOceanPro Viewer by Rezak from the user support at Mercator Ocean. And then we will have a presentation about ocean reporting by Karina von Schuckmann. So she's a physical oceanographer in the scientific direction of Mercator Ocean, and she's the first author of our latest ocean state report that was published last year. And after a short break, we will have two presentations about specific application of these Copernicus marine products. We'll have Manel Grifoll from the UPC Barcelona Tech, so the Polytechnic University of Catalonia. And then we will have a presentation by Achille Ciappa, a former oceanographer at EGEOS and now a collaborator at the University of Naples in Italy. And yeah, so it promises to be a very interesting morning, and I hope you enjoy it. And now we will jump right through the first presentation, which is a little overview about what the Copernicus Marine Service is about, just to introduce you to it, if you don't know anything about it yet. So Copernicus is a program created by the European Union. So it's a European fully funded program dedicated to the observation of the Earth and to better understand different systems of the planets. So it includes several services of monitoring, so about on the atmosphere, on the marine environment, the land, the climate change, and the emergency management and security. And yes, so Copernicus provides information and free of charge data, open source data products about all of these different systems of the Earth. And obviously the marine service focus on monitoring the marine environment, which is overviewed by Mercator Ocean International. So how do you access the service? So it's through its website, Copernicus Marine. It's free to access the website and to download any product. You will find an extensive catalog of products. All of them are scientifically qualified and they are user-driven, so they are constantly upgraded and improved. and we also take into account the experiences of the users. Okay. So what kind of data the Copernicus Marine Service provide? It provides data on the blue, the green, and the white oceans. So the blue is all about the physical component of the ocean, so the currents, the waves, temperature. The green ocean is the biogeochemical component of the ocean, so everything that has to do with phytoplankton, nutrients, oxygen, etc. And finally, the white ocean is, well, basically ice, so all that has to do with ice coverage, ice velocity, and yeah, that sort of thing. And concerning the portfolio, so you can find these are just a few examples, but in terms of temporal and geographical coverage and the type of data the Copernicus Marine Service provide, it is quite varied. So it includes in situ data, satellite observation, and then which are used to validate model data. And then you can find data that are measured right now, so what we call real-time data. But we also provide data in the past, so all the way back from 30 years, so the multi-years or reanalysis data. And finally, we also provide forecasts 10 days into the future. And yeah, in terms of geographical coverage, we do cover 5 areas or 6 regions, as you want to call it. So we have the global region, which is basically all around the world. And we have also 6 smaller regions around Europe, as you can see on the map. You will also find on the website, if you go take a look, a visualization tool, what we call MyOceanPro. So we will have a demonstration by Rezak just after my presentation. And you have 3 versions of this tool, the Learn, the Lite, and the Pro, so we will have the presentation of the Pro today. And it's just to show you how you can select a product and see it or visualize it in a very fun way. And we also have specific products like ocean monitoring indicators or data related to the climate. So in this case, the monitoring indicators are key variables that help us understand the state of the ocean. They are also accessible and free of charge, and they cover the past 30 years or so. We also provide information beside data, so you will have a better explanation of this during Karina presentations, but basically what we do to provide information is publishing a yearly report on the state of the ocean, and we also provide the Ocean State Report Summary, where we try to target more or less scientific communities, so more policymakers or the media or just the general public. And to make sure the information gets to everyone, we do that by creating 2 pages called the Ocean Explainers and the Ocean Climate Portal. So we'll have also more detail later on. And we explain some oceanographic concepts or current threats that the ocean is facing. And we try to explain it to everyone. So yeah, it's just a perspective on the case variables of the climate, but in a more accessible way for everyone. So as you can see, we try to reach a bit of everyone, and it's the data we provide and information. It responds to different needs or blue markets, as we call it. So it goes from science and innovation to policies, but also to coastal services or economic sectors. And for example, today you will hear about 2 practical applications of the data we provide, but in the website you will find many other examples, and we invite you to visit the website and learn from this example. And also, if you are a use case yourself, we invite you to submit your project as a use case. We will put you the email address in the chat where you can send the use case you have if you use Siemens products. But yeah, we are always interested to learn more about how the data has been used, and maybe you can join us on one of these events to present your work if you want. And yeah, beside this, we also try to make sure that the data is not only available, but also that we can help people use it. So we make it as accessible as possible. So we organize workshops and webinars like this one, but we also have hackathons, forums, and lots of tutorials that you can find on the website. And yeah, so that's all for me for today. I hope you got a little glimpse of what the service is about. And now we will dive a little bit more into the product itself and later on the specific application. And yes, so now I'm inviting my first speaker, so Rezak from the user support team, to give you a demonstration of MyOcean Viewer. Hey,
Thank you.
Rezak.
Hello, everyone. Thank you, Gael. Can
And yeah,
you
we
see
can
my
see,
screen?
yeah, we can see your screen. Thanks.
So, good morning, everyone. I hope you're doing well. I'm Rezak from user support team, Copernicus Marine. Today, I will be presenting one of the main tools used to visualize and retrieve Copernicus Marine data, which is the MyOceanPro Viewer. To access it, it's really simple. Once on the Copernicus Marine website, you just go to the Access Data section here, and then scroll down to the Ocean Visualization section. So you click on it, and as you can see, we will be getting three different versions of the tool. So first we have the MyOcean Lite, the MyOcean Learn, which is a version dedicated to beginners. And then we have the MyOcean Lite, which is an intermediate version of it. And finally, we have the MyOceanPro Viewer, which is the version that contains all the features and options that allows you to manipulate, visualize, and also download Copernicus Marine data. So to access it, you just click on Explore My Ocean Pro. And now, once on the interface, as you can see, we have various options that you can use to have the best experience possible when visualizing and also downloading our data. So first, you can change the projection to the North Pole, for example, in case you are studying a product within this area. You can also go back to the equatorial projection or switch to the South Pole projection. You can also, with your mouse, by maintaining it, go to the left or to the right to have a better access of the region of your interest. You can also zoom in or zoom out with your mouse wheel to get, of course, better access of the region of your interest. Here below we have the time scale, which tells us when the data is available. For example, here in our case, we have the seawater potential temperature layer, which is displayed. If I go beyond the scale, then the variable won't be displayed anymore. And on the right here, we have a little scale also to manipulate the depth range based on what you need. Now on the left, we have the layer window, which allows you to visualize the variable you are exploring. And when maintaining your mouse on the variable, the seawater potential temperature in this case, you're going to see the product and also the data sets within the variable is contained. The eye here, the eye icon allows you to show or hide the variable. If I click on the eye, then as you can see, the variable is no longer displayed. If I want to display it again, just click on the eye and the variable will be displayed again. So now to add the new layer, it's really simple. Just go to the plus here and click on it to add the layer. And then you will be accessing our data store where all of our products are available. We have nearly 300 products. And of course, each product with its own specificity. So we have data, different acquisition modes. We have models, we have satellites, and also in situ observations. And each product contains uh, the spatial resolution as well as the temporal resolution and the variable contained in it. Here on the left, in the filter section, we have various filters that we can apply to get the variable that you need. So you can enter the time range. You can also select the depth. You can also select the universe, which is the region you are interested in, also the variables to explore. You can also select the temporal resolution as well as the sources. For example, today we are going to explore a global ocean product, and for that you just click on global ocean, and we can choose one of the variables that we want to explore. In this case, we can choose the velocity variable, and I can also select the temporal resolution for that. And let's say we want to take the hourly data sets. So now, based on the filters that I applied, I will get a set of products that are suited for my selection. So let's take the global analysis and forecast. When clicking on it, you will be getting a window which displays an overview of the product, of course, where the product is defined, as well as all the metadata contained in it. All of that is contained in the description section. The notification section displays the maintenance and also the incidents that occurs on the product in case you want to track them. The data access section contains all the data sets as well as the variables contained in it. Of course, each data set contains three different options. So we have the subset service, which allows you to download subsets of data. We have the file service, which allows you to retrieve the original data. And also we have the WMTS service, which allows you to get images of variables within a certain area of your interest. So if I click on the information icon, for example, I will be getting the article explaining the subset service. In the contact section, you can just click on the chat that will redirect you to our user support interface in case you have any questions or you need help. In the documentation section here, we have various documents which explains all the needed information on the product. So we have the user manual, the quality information document, the synthesis quality overview, the product quality dashboard, roadmap, which explains the future releases of the product. We have also the license and how to cite in case you want to cite the product in a given article or research. We also have here the share icon, which allows you to copy the URL on of the product in case you want to share it. So now let's add a variable to our layer. So as you can see, we have a window here which displays all the data sets, each one, of course, with its own time resolution. So we have the hourly, the daily, and also the monthly data. So for today, as I said, we can explore the seawater velocity for the hourly time resolution. So for that, you simply click on Add to Map, and our variable will be added. So once on the interface, as you can see, we have now two different layers. So an additional option is that you can change the order of the two layers just by maintaining your mouse and drag up or down based on what you need. We can also choose to hide the seawater potential temperature since we are just going to explore the seawater velocity. You can also choose to remove a layer just by clicking on the cross, and the seawater temperature will be removed. So now, speaking about the seawater velocity, within this one, we have three different icons here, which allows you to characterize your visualization and also your downloading. So we have the download icon, which allows you to select your data to download, which I'm going to present in a few minutes. The information icon here allows you to display the window that I have presented, which is an overview of the product, as well as all the documentation needed to read about the product. We have the layer icon here, which allows you to change the variable to display in case you want to display another variable within the same dataset, or totally change the dataset to choose another one. The gear icon here allows you to characterize your displaying. So first we have the style. So I will zoom in to this area, for example, to get a better visualization. And we can change the style to only display the seawater velocity in solids. And as you can see, we will be getting seawater velocity in solid form. We can also display it in solid plus vectors, and then you'll be able to see vectors. We can also choose to only display vectors or only particles. The opacity also can be changed. You can either decrease it or increase it just by dragging with your mouse. And also we have the color map option, which allows you to change the nature of your color map. For example, if I want to change the visualization of my map, just click on a given style and you will be getting the style that are related to this one. Of course, we have also the minimum and maximum value corresponding to our displaying. These values are displayed here in the scale below my variable. So here within the color map, I have three different icons. The first one, the two arrows, allows me to invert the maximum and minimum value. So when clicking on it, you're going to see that my maximum and minimum value are inverted, which result in changing the display. If you want to get back to the first display, you just click again on it. The steps icon here allows us to add or remove thresholds in case you want to add or remove them. And finally, we have the final icon here, which allows you to mask the outlier, which basically means that in case you want to remove all the values that are not contained within my range here in the scale. So if I click on it to remove it, as you can see, all the values that are not contained within the scale are removed. If you want to go back again, just click again and you will be getting your first visualization. We have also the log scale. You can either enable it or disable it. For that, you just click on it and the log scale will be activated. If you want to go back again, just click again on it and it will be disabled. So here on the right, we have also the possibility to select our coordinates on the map. And for that, we can select points. Just click on points and select it on the map. You can also select lines like this. If you want to disable the option, just click on escape on your keyboard and it will be disabled. So we can also choose to hide this window here to get a better visualization. Just click on this arrow and it will be hide. Going back to our options here, you can select also an area. So you go back to the map and you draw your area of interest. Again, escape on the keyboard. And now we have three different tables. Of course, each table contain the geographical coordinates of the selections as well as the values of my variable displayed within a certain period of time. And of course, within each graph, I have different options. If I go to the 3 points here, as you can see, I have the possibility to export my graphs into a netcdf, a CSV, or SVG format. Of course, to enable this option, you have to be logged in. So let's say, for example, I'm logged out, go to setting and log out. Then I will no longer be able to export them. Of course, you have to be logged in for that. Log in again. And now I can export my graphs to the needed format. And of course, here at the end, I can choose to remove a given graph. Just click on remove and the graph will be removed. An additional option also, you can choose to merge a selection within another. So just drag a given table within another, and you will be getting the two tables merged with all the needed information about that. So now the import option allows us to select presets. So presets are basically predefined region in case you want to study one of them and explore the data within it and download it also. The recent section here allows you to upload the presets that you have selected here. You can also choose to upload a WKT, a GeoJSON, or a shapefile based on your choice. The setting option here allows you, of course, as you could see, to log in or log out. It also allows you to characterize your map in case you need to change the style of your map based on what suits you. You can also choose to show toponyms to know which region is from another. You can also choose to modify the geometries, the units, and also the miscellaneous parameters. So now let's go back to our downloading icon. So let's say I want to download my data. For that, I will click on download, and I will remove this one just by clicking on the cross. So I don't need the lines. Now let's say I want to download this area. So to download it, you have two choices. You can either enter the geographical area manually, or you can just go to with the define on map option. And for that, it's really simple. Just click on it, define on map, and then go back to the area that you have selected, click on it, and as you can see, the information are automatically filled. Same thing for the date range section. You can choose to select your start and end date manually, or you can do it with the as in map option here. So let's say I want to download the data from the 6th of February 2025. Just click on as in map to the, let's say, to the 10th of February 2025, again as in map. So now I have my data ready to be downloaded. So within this one, you can also choose to also download another variable within the same data set, like for example, seawater salinity, or you can choose to add them all based on your choice. So now for downloading the data, we have three different options here below. So we have the browse files option, which allows you to retrieve the original data. Just keep in mind that with this one, you don't have the choice to select a variable. So if you go with this option, you will have to download all the variable in a given data set. The automate section here allows you to get two different templates to download your data. So you can either use the command line interface or the Python API. So these two templates are used with the Copernicus Marine Toolbox, which I'm going to present in my second presentation. So if you are using, for example, a Python API, just click here on copy, and the template will be copied, and you can just paste it on your code, and the data will be downloaded based on the information that you have put it in this table. Or you can just simply download the data directly by clicking on download manually. So just keep in mind that when downloading the data from this interface, there is a quota limit that you don't have to exceed, which is 800 megabytes, unlike the toolbox where you are free to download any memory quota as long as your machine can handle it. So here also we have three different options. So if you go to the message icon here, for example, click on it, you'll be getting a window within where you can ask for help. So in case you need further details on how to use the tool, you just go to the help icon here, click on it, and you can search in our help center on how to use the tool. Let's say, for example, how to use the MyOcean Viewer Pro. So, and then you will be getting a bunch of articles which explains the tools. So let's choose this one, for example. So in this article, you will be getting all the features that I have explained here with examples, of course, that can help you to get started with the tool and get more familiar on how to use it. If that does not answer your question, you can also go to the message icon here and ask Blue a question. Let's say you want to ask Blue, our chatbot, on how to use the tool, how to use MyOcean Viewer Pro. So you ask your question, and what Blue is going to do, that he's going to explore our data store, our help center, and search for the best suitable answer to your question. And usually at the end, Blue gives you also access to sources which will guide you to the articles that you need to consult in order to get the information you need here in the source section. If it still doesn't not respond to your question, If you need more details, you can just go with the talk to a person option. This will redirect you to us, the user support team, and we will be glad to help you out and assist you further in your request. Here, the share icon allows you to share your activity. So you can share it either by a link or an image or a video or also with an embedded link based on your choice. Finally, we have the information icon here. If you click on it, you will be getting some tips on how to use efficiently the tool. Basically some keyboard and mouse tips to help you to optimize your activity on it and get the best possible experience. So that's it for today's presentation. We have explored all the main features of the tool. And please, if you have questions, don't hesitate to ask them. I will be glad to answer. Enjoy the rest of the event, and thank you, everybody.
Thanks a lot, Rezak, for your nice presentations. It was really interesting, as usual, to see that. And yes, so we have a few questions for you. Okay, just wait to go to the question. Oh, that's not the right window, sorry. That's the poll. Oh, wait a few seconds to go to the Q&A. And okay, now we can. Okay, thanks. Okay, the first question being, can we save our progress or history to continue our work later or to make some corrections or edits?
Yes, of course. Usually when you trying to download or visualize a given data or when you have added a layer, it's usually automatically saved. Of course, if you didn't close your tab, the activity is saved. As I said, also you can choose to let's say go to with the share icon and share your activity with somebody either by a link or an image or an embedded link. So yes, it's possible to save it. Your work
Okay.
is automatically saved when working with the MyOcean Viewer tool.
Okay, thanks a lot. Okay. One question about the data. Is it possible to navigate through monthly, weekly, average data?
Yes, it is possible. As I said, uh, this is possible by going to, let's say that, as I said few seconds ago, so I'm exploring the seawater velocity. In case you want to explore another variable, you just go to the layer icon and you will be getting all the other data sets and all the variables contained in it. And you can choose to change the time resolution. So by going from, for example, from the hourly data to the daily data or the monthly data. So yes, that remains possible. And just select the variable that you need to explore, and you will be getting the new variable and you will be getting the new data.
Okay, okay, thanks a lot. Okay. A question also on the data. Can we extract on the water column or just surface parameters data? I guess it depends on the product.
It depends on the products, and when we say extract on the water column, I mean, there is the depth range that you can choose to explore based on the variable that you are studying, of course. And I don't know if this is what the user wants to mean
I think
by
it's, yeah, can we extract data on several level of depths, probably in the
yes,
same file, but yeah.
yes. If it's the case, then it is possible. As I said, there is the on the right we have the depth range in which you can choose your depth range that suits your needs. So yeah, it is possible.
Okay,
Of
okay,
course, that
good to know.
depends also on the variables, of course.
Yeah, okay, thanks. Okay, next question. Is it possible to select specific predefined areas such as the Black Sea or Mediterranean Sea for data analysis?
Uh, we- I yes, it is possible in the import section. As I said, there are presets, and those presets are predefined area to study. So uh, within the available ones, I think you can let's say for the Black Sea or Mediterranean Sea, yes, there is a preset that you can select, which includes the Mediterranean Sea or the Black Sea, or you can just simply drag your area using the area option here and select the area that you need to study, and then go to the downloading area and automate it as I've shown in my presentation. So yeah, that is possible.
Good to know. Thanks again. Okay, the next question about the viewer. What is the programming language used to analyze the ocean data using MyOceanViewer?
The programming language for the MyOceanViewer, I'm not sure of it, but the user can ask us the question through the user support interface. We will search through it and we will give the right answer. I don't want to give an answer perhaps that it's incorrect, so yeah.
Yes, I understand. I think maybe it's something like Java or some
I
maybe
want to say
Python.
Java, but I'm not sure. So if the user
Okay.
wants further details on that, he can contact us to the user support. We will go through it and give it the answer.
Okay, no worries. I put the question on the side also.
Yes.
Okay. This question, in which specific document can we identify what satellites or sensors have been used to produce the data set?
Yes, to get all the scientific details on the product, like I said, there is in the documentation section, when accessing the product, we have a documentation section which contains the user manual and quality information document. These two ones are usually the documents that contains all the necessary details, scientific details, and also on the data sets and the variable used, the type update, and other various options, the acquisition modes. So if the user is looking for this information, and then it's in this within this document that he can find it.
Okay, good to know. Thanks. Okay. Next question. Can we use the data? Oh, sorry, no, okay. Can we use the data through API in external application?
Um, yes, the data can be used through an API, but in external application, I don't know what it means in this context. Of course, the data
Yeah,
can be used in another application for another use. It is possible, but I don't exactly understand which means external application.
yeah, I'm not sure
But
if it's like
but
just use
all,
the data in Python
all
or something else.
yes, all the users that contact us or generally use the manipulate the data in the Python interface using the toolbox, of course, and usually they are developing their own applications. So I would say that it is possible to use our data to explore and to analyze within another application.
Thanks a lot. And if that wasn't the question, the person who asked that can still upload the question with more detail if necessary. Okay, a few more questions. Is it possible to download the map or graph in JPEG or PNG format? I think you can do video on MyOcean, but I don't know about picture.
Yes, you can, as I said, you can share your activity of in the tool by sharing a link or an image. It is possible to download an image, but as for the format, I'm not sure of the format that you can use. Yes, it is possible. I've just downloaded an image and yes, it's in the PNG format. So when downloading your activity, it will be an image downloaded in the PNG format. So it is possible.
Okay, thanks. Good to know also. Okay, next question. If I download the daily dataset and choose 3 days, will I get 3 different bonds in my roster?
If I download daily datasets,
I think you will have
uh,
just one file.
exactly when downloading a daily datasets uh, within 3 days, it's usually coming in a uniform netcdf file that that then you can open using QGIS to add the raster layer. So yes, this is the way the process works. And of course, if the user needs further detail on that, you can always reach out to us using the interface, and we will go through it in details and give it the best possible answer.
Okay, thanks a lot. We have time for 2 more questions, I think. Okay, so the next question, is it possible to download data in CSV or JSON format?
It is indeed, it is indeed possible to download the data in a CSV format. I mean, we have various articles in our Help Center which explains how to export our data using the toolbox from a netcdf to a CSV. You can also convert it once you have downloaded in netcdf to a CSV format. As for JSON format, I am not sure of the information, but I will check it and then give it the answer. But for the CSV, yes, it is possible. It is also possible to export your activity here, like I said, on the graphs in the tables. It is possible to export the selections into a CSV or SVG format. So,
okay,
yeah.
thanks a lot. Okay, good to know. And yeah, one final question. Can you select a point or polygon in the map by setting the coordinates manually instead of clicking for more precision?
Can you select point, polygon? Yes, of course, it is possible. You just have to go to the download icon, and you have the where you have to fill the geographical area. As I said, you can put, if you have those coordinates, then yes, you can put it, and it will manually select the area that you have chosen, and yes, and then download those data.
Okay,
So
good.
yes, it's possible.
Okay, thanks a lot. So we will have to
Pleasure.
stop there for the question. Thanks again, Rezak. For the unanswered question, we will put them together in a post-event report, so no worries. And yes, thanks again, Rezak. We see you in 2 days for the Copernicus Marine Toolbox.
Thank you, everybody. See you in 2 days.
And yes, so now we will go to the next presentation, which is about ocean reporting at Mercator Ocean International. And I welcome Karina to do her presentation. Welcome, Karina.
Thank you very much, and welcome everybody to this training. And I have the pleasure to introduce some of our activities with respect to ocean reporting, and I'm happy to reply to your questions. So, So I wanted to start with a bit the rationale, let's say, why there is such an important relevance to continue to provide evidence-based information on the ocean from all the data and combined with the scientific knowledge. It is because that we are faced, or the ocean is faced to unprecedented change and pressure, and which is called also the triple planetary crisis, such as climate change, pollution, and also biodiversity loss. And on top of this triple planetary crisis, we have also overexploitation, for which the ocean is highly under pressure. So this is a major rationale to ensure that the transfer of science-based knowledge, and which is particularly relevant not only for awareness raising on a wider audience, but also particularly on the science policy interface to drive ocean-related action. In addition, with respect, this is also reflected, this sense of emergency at the international policy landscape. So this is just an overview on the major components which are currently undergoing at international level. So which have reflected that the elevation of the ocean is a prominent role in the global diplomacy. And again, its importance, it reflects also its importance in the Earth system. So, for example, on the left-hand side, you have a kind of overview on the different, let's say, tools at the international policy level, such as agreements and treaties, sustainable development, convention, governance, and centered and backboned by the data, science, and services we need in order to ensure evidence-based information flow. So Copernicus Marine has put in place and launched in the year 2015 an activity on so-called ocean reporting, which consists of several tools. So there's 3 big components. So it's science components with the development of the Ocean State Report, the science to service with the provision of ocean monitoring indicators, and the science to communication element with the establishment of the summary of the Ocean State Report. So this is backboned by Copernicus data, but also on other data sets. And it is driven by expert assessment, which is providing information on the state, variability, and the change of the European regional seas and the global ocean, with the objective and having these different components to also enlarge the way and how we can reach different type of audiences. So where are we now today? So we have again started this activity, as I mentioned before, in the year 2015, with the publication in 2016 of the first issue of the Ocean State Report. Now we are currently have launched our anniversary cycle with the publication of the 10th Ocean State Report expected for September in 2026. So it's currently ongoing, and the 9th issue, which will be published in September this year, is the issue number 9, which is currently under review. So it's an annual publication of the Copernicus Marine Service implemented by Mercator Ocean International, and it provides, as mentioned earlier, state-of-the-art reference for the variability, change, and state of the ocean, including methods and tools, relevant scientific knowledge, and also to pointing and further understanding and explaining what happened recently in the ocean environment. It also provides inputs, key inputs that support major EU and international policies and initiatives. And this is the most important part. This work is backboned by a lot of expertise, so fluctuating of around 150 scientific experts in Europe and abroad from different European and international institutions. So how is this organized? The Ocean State Report itself. So this is the scientific component, which is, again, written by scientific experts and passes a peer review process. And it is organized across 4 chapters. So we have chapter 1, which is providing the synopsis of the ocean state over the past decades. Chapter 2 is providing novel scientific analysis of the ocean at various space and time scales. Chapter 3 is highlighting the ocean case studies of socioeconomic relevance, and Chapter 4 is pointing on the unusual events which have taken place in the ocean. And so for this year, Ocean State Report 9, there will be several topics with respect to what happened unusually in the year 24. So this is just an example of what we have evolved in Chapter 1. So Chapter 1 was a very evolving part, and we have built regular information, which is along a different set of indicators. It's just an example for what we have done in a regional. So we have used a global aspect, but also a regionalized aspect. This is the example for the Northeastern Atlantic at adjacent seas, where you can see that there's on one hand the global scale change compared, set in context to the regional scale change, and put together also to show the different areas here as an example for the Copernicus marine regions on how the surface temperature has changed on average for the different basins. Also giving a glance on the view on the regional aspect to see that, for example, some areas are warming much faster than others. Then I would like to come then, so as I said, this regular reporting just mentioned as Chapter 1 in Copernicus Ocean State Report. There's also this element of the indicators. So the indicators are a concept which are sitting, let's say, at the center of the so-called added value chain, which you can see on the left-hand side. So we'll start with the raw data in the concept of a sustainable development of the 3 pillars for the environment on the bottom and society and economy. So, and you add expertise, research and development, and you come up to the products, the different products, for example, the grid fields, the models, etc. And then if you add additional knowledge and expertise, you come up to the concept of ocean reporting and ocean monitoring indicators. And those are sitting directly at the edge for the transfer of knowledge between the environmental pillars, the society and economic pillars. So these indicators have a multifaceted role, so they can do many things. So this is just an example of the many things they can do. So they can facilitate different research priorities on the themes. They can foster international multidisciplinary collaboration. They can interlink different types of products, such as observation models, but also they're an essential block for the science and policy nexus, also for assessment and reporting, as just mentioned, and also for literacy and communication, but they can also drive research and development innovations and be a very powerful tool to assess also observing system capacities. So the Copernicus Marine Service had put in place a framework on ocean indicators. So this is just an example where you can access online. You have also here the link to the ocean indicators, which is providing information on, for example, on themes like ocean circulation, ocean climate, ocean variability and extremes, and ocean health, where you will find a set of different types of indicators from global scale down to regional scale. These are just some examples of those monitoring indicators. Here's, for example, on the left-hand side, the sea ice extent in the Arctic area, where you have access to the figure, which is regularly updated. You have also access to the numerical values. And there's also a short, concise scientific background provided, which is drawing also on the main outcomes, what we can see with this update with respect to align to the regional monitoring assessment based on ocean indicators. On the right-hand side, you can also see an aspect of a more regionalized approach with respect to the regional map of trends for the sea level as derived from satellite altimetry. Also, those are available also with the uncertainties in as ocean monitoring indicators and numerical values. Then, as mentioned already earlier in the introduction of this training session, is this tool on the summary of the Ocean State Report, which is drawing on both the Copernicus Ocean State Report and the ocean monitoring indicators. So this is a report which is also worked together with not only with science expertise, but also with expertise on communication and expertise on design and concept drawing, so that this information can be made available to a larger audience, such as the wider public or the policy. So this is just an example where we have an overview. This is an example from the last one, from issue 8, where we can see an overview on the big glance on the major events and highlights we could pick with the publication, the scientific work. And this is another example where we draw on the different indicators. So this is the indicator base. We update also every year to have aspects of the green ocean, such as biogeochemistry. Here's an aspect on ocean acidification, or the white ocean, we call it. It's with respect to sea ice extent, also, which is related to what is happening in the cryosphere ocean, and the blue ocean with respect to sea level rise, surface temperatures, or ocean heat content, for example. And we also combine the themes, the results with different aspects, such as put it into the context here of the SDG framework, or discussing the importance of data and knowledge and indicators for driving ocean governance. And so we pick each of the year different themes which are related with respect to the outcomes in the Ocean State Report. And we also highlight the outcomes with respect to Chapter 3, for example, where we draw on the different innovations linking the ocean data and the ocean information to socioeconomic relevance. Here, 2 examples, for example, for the seawater heat, for renewable energies, or data and results in support of fishing and aquaculture. So, I'm happy before the coffee break starts to answer you some questions. Please.
Thanks a lot for your presentation, Karina. It was really interesting to have more detail on the Ocean State Report and other information. So we can go to the question. Just put them on the screen. Okay, so the first question, What are the differences between the Ocean State Report and the IPCC reports, or how do they complete each other?
Yes, thank you for this question. So yes, it's quite straightforward. So in the Ocean State Report, we are really doing research. So these sections are developed from the authors. These are new results. We're working with the data to provide new understanding of the ocean, but to provide also new tools or new concepts for indicators, etc. The IPCC report is an assessment report. IPCC is not doing research. What IPCC is doing is to draw on published material, such as the Ocean State Report, and to assess this material in order to give an overview on the current state of knowledge we have. So let's say, how do they complete each other? The Ocean State Report is also cited in there. So it's a material which can be used in order to perform the IPCC assessment reports. With respect to the regular reporting we do on the indicators, I don't really want to say complementary, but it provides also an opportunity to get between different reports, such as IPCC, but there's also the World Ocean Assessment, etc., which are on different timescales. We have an annual timescale, provide annual overviews, annual updates on the ocean, while those reports are much more fundamental, drawing on, again, on all the published knowledge we have on peer review, but at a timescale, for example, 5 to 7 years. So IPCC 7 years, World Ocean Assessment, others is IPBES, etc.
Okay, thanks a lot for the explanation. I think it's clear for everyone, so thanks. Next question about the ocean monitoring indicators. Can we use the ocean monitoring indicators in our work?
Yes, thank you very for your question, and more than welcome. And the more you use it, this is why this work is in place. So you use it. You can also contact us, and if you have questions, we are working also on improving also the update frequency. And yes, so please go ahead. There's always a DOI with respect to each indicator, which also allows to facilitate also the use in terms of if you use it for publication, so that you can provide the reference. We have documentations in there. Either there's for sure always an Ocean State Report section to give a reference also on the methodology. So there's a whole tool which allows to either use it even for scientific publications, so where you have also reference to show that this is something which is robust, but it can be also used for other applications. I don't know from where the question is coming from, but yes, they are free, downloadable as the data. So
Okay.
welcome.
Okay, good to know. Thanks a lot. Next question. Is the Ocean State Report significant for technology scientists? How can it contribute to projects related to technical writing?
I think with this respect to the question, I think there are two aspects which could be very relevant here. So the first is really the aspect of chapter 1, and we are going at it show because we are still working on this, but we plan to have also evolutions there in chapter 1, where we want to establish a link between the environmental pillar, let's say the indicators, and the socioeconomic indicators. So I think that will be very relevant also for a specific technical writing. And also I think that more the indicators will be also very relevant in order to use for technical writing, to have to be able to use indicators, download them, calculate statistics, and underline the specific themes also with technical writing. So if I hope I could reply to this question, because I don't have the specific theme.
Thanks a lot. Still a nice answer. Okay. A small question. Is there information in Spanish too?
So that's a very good question. Thank you very much. So we have started to work also on translating the summary. So we will not do this for the big report because it's peer reviewed and usually going in English and working together with a scientific journal. But the summaries we start to translate. So we have started with French, but more plans are ongoing. So I don't have a timeline, but this is in the pipeline.
Okay, so yeah, it will happen, but yeah. Okay, thanks. Is there a possibility to volunteer, to collaborate with the Ocean State Report elaboration?
Thank you very much for this question, which gives me the opportunity. I should have said this, and my bad. Yes, the contribution to the Ocean State Report is open. Everybody can contribute, and we usually have a call of contribution where we collect different suggestions with a short abstract and to get an understanding of the theme proposed. And so it's open. The only constraint is that you have to use at least one Copernicus marine service product, but it can be combined with other products. And so the call of contribution is usually open between December to end of January each year. You can always contact me and also contact the service desk. So if you don't find the information, but yes, you're more than welcome to contribute. It would be a pleasure. And also to connect with the network. There's also opportunity to connect with the network of authors to combine some themes as well, etc.
Okay, thanks a lot. Okay. Okay, I think these two are more open questions, but what are some of the most important ocean indicators that help us understand the health of marine ecosystems?
So this is a tricky question. So I think there are many aspects one has to consider with respect to the health of marine ecosystems, and which are, of course, those indicators which are directly linked to the status of the marine ecosystems, like, for example, species status, etc. I come with my head from the physics science and also with respect from major changes facing, if we look, for example, at the aspect on ocean warming, on the climate change. So this is ocean warming. So because marine ecosystems are very sensitive also to the changes in temperature, but also the ocean acidification. So also acidification is, for example, also one indicator which is included in the planetary boundary concept, which is also showing that we are starting to approach that boundary of safe space for the planet. With respect to ocean acidification. It depends also on the area. It can be also very relevant to look in the cryosphere area with respect to sea ice changes, which has also impacts on the marine ecosystems, etc. But again, this is only from the aspect for the physical biochemical side. And then there are, of course, many indicators with respect to the marine ecosystems, the biodiversity indicators.
Thanks a lot for the good explanation. And yeah, I guess that answers a little bit the next question, how the ocean indicators relate to climate change and human activities.
This is also a nice question. I could, if I would have more time to talk a bit more, but you can also contact me and we can discuss. And the ocean is very central for climate. So the ocean provides a lot of services to humanity. And I give you just one example. There are provisioning services, etc., cultural services, but also there's a service of regulating service. So it's just one example as a matter of time I can give. And the regulatory service is that the ocean is taking up 90% of the surplus heat, which is in the Earth system from greenhouse gas emissions. So it's 90%, so it's mitigating. It is also taking up about a third of CO2 of carbon emissions, which are in the atmosphere from human activities. And those two big components, again, these are just some examples, they come as a cost. So as a consequence of taking up the 90%, the ocean is warming. And this affects, as we said just before, for example, marine biodiversity, for example. Or it is a major component of rising sea levels. The ocean is warming. And that the ocean is taking up 1/3 of carbon is also coming at a cost. Ocean acidification is taking place. So these are just some examples, and there are several ways of narratives to underline the importance of the ocean for all of us.
Thanks a lot. And I think we have time for one more question. What advice would you give to someone with data analysis, research assistant background, hoping to enter the ocean reporting and management space?
Yeah, I think what would be very interesting here is to really start to get familiar with the transition from what I've shown before on this added value chain, where you start to look at the different products. You have the created products, and to start to look into the expert knowledge, and to start to develop this type of indicators and start to calculate this type of indicators. For example, from regional scale, from global scale, and then to regionalize, to understand how does this meet, what are the limitations of my data, and how can I interpret this? Because it's a very interesting approach that many of those indicators have been started to be used, such as, for example, IPCC at global scale. But today we have to regionalize, because we have to support the different actions we need to take, such as, for example, adaptation. For this, we need regional information, and for this, we need to understand how the ocean regionally changes. But it's not that straightforward, because there are a lot of variations taking place at a regional scale. There have also limitations in the data. So I think a nice starting point would be to start to play around with these indicators, try to calculate them at regional scale, compare with the indicators which have been calculated, which are online, to see where this goes. This could be a very nice starting point, and then maybe contribute and work with us on the Ocean State Report if you like.
Okay, thanks a lot. And I think we have time for one more question. So about the safe boundary, so the safe boundary measure for planet Earth is very important. Can you provide further input on that or link to papers on this?
Yeah, that's a wonderful question. So this concept is looking at different aspects on the planet Earth, not only on the ocean, and identify this type of boundaries in order to understand which are very relevant for well-being, and which are important to the functioning of planet Earth as a whole. And if you look in the importance of the ocean, there is one planetary boundary which is called the climate change. And there are two thresholds, and one of these thresholds is the ocean, because it's a so-called energy imbalance, and this can be calculated by the 90% of ocean warming, as I mentioned earlier, and then the aspect of the acidification. Discussions are ongoing, and to also say we have to increase this, because the ocean has to say much more here, and there are discussions ongoing at international level to expand also this concept of the planetary boundaries with a more insight on the ocean. For the publications, papers, yes, you can send me an email, but otherwise this paper is, the founding paper is from Rockström in 2009. And others are on the Stockholm Resilience Center. If you type Stockholm Resilience Center and planetary boundaries, you also directly will find the link, because they have just published also a new one last year, where they show then the updates and how they have evolved, and that we are more and more reaching this type of boundaries.
Okay, thanks a lot. So I noted the name of the Stockholm Resilience Center. Thanks again, Karina, for your nice presentation and the Q&A. It was really interesting and really nice to have you. So thanks again.
Thank you.
And yes, so for the participant, we are going to do a small coffee break of 10 minutes before coming back for the use cases. So feel free to chat with each other in the chat room, or don't hesitate to take a look at the polls, or even if you have a use case to submit, to contact the email address we send you. And yes, see you in 10. Okay, welcome back everyone. So now we will go to the use cases part of the training, and I welcome the first use case speaker. Hi Manel.
Hello, can you hear me, I guess?
Yeah, we can hear you.
Okay, thank
And
you.
welcome.
Okay, good morning, everybody. My name is Manel Grifoll. I'm Associate Professor from the Universitat Politècnica de Catalunya, Barcelona Tech. And the title of my presentation is a SimRoute, that it's a software system that it's useful to provide a comprehensive ship weather routing system using the Copernicus Marine Service. I think that this presentation may provide you some inspiration about the use of Copernicus Marine System. Well, first of all, let me to introduce my institution. It's the Laboratory de Enginyeria Marítima at the Universitat Politècnica de Catalunya, UPC Barcelona Tech. It's a public university specializing in the STEAM fields with more than 30,000 students and about 30,600 academic staff. And the LIM is the referent research lab at the university in the field of coastal, port, and maritime engineering, thanks to the capacity that we have to do experimental activities in our lab, also to carry out field campaigns and numerical modeling in different research projects and technology transfer initiatives. So, which is the motivation of my work? If we have a look about the global transportation split by mode of transport, we realize that the ocean freight is about 70% of the total mode of transport. So it's the most used transport in the global transportation system. And in the left-hand side, in the figure on the left-hand side, you can see how the annual percentage change of the maritime transportation is increasing every day, exceptuating the COVID years and the last oscillations due to the adjustment of the maritime shipping sector. But it's a sector that probably will increase in the next year. So the maritime transportation in the global transport system is quite relevant. And if we check the global emissions by sectors, even that the transportation just covered the 16%, and in particular the ships, it's only a 2%. So we can assure that it's a relatively clean mean of transport. However, the importance and also the potential increase of these sectors may or involve us to look for a more energy efficient system. And in the left-hand side, in the panel, you can see how is the ocean freight cost breakdown by different sectors or by different components. And we realize that the fuel cost, it's the most important, is the 50% of the total ocean shipping sectors. So we need also to look for energy systems that help us to reduce the fuel consumption by ships. And also, additionally, to reduce also the transit time and also to increase the safety navigations are challenges that may be addressed in the ocean shipping sector. So what we can do, and that is the question that we have addressing in the recent years. Well, I present what is a ship weather routing. Here is the canonical definition of a ship weather routing. It's the development of optimum sailing course for ocean voyages based on the nautical chart, the forecasting sea conditions that here we can imagine that it's that we will use the product of Copernicus Marine Services, and also the captain experience and the individual characteristics of a ship for a particular route. So I will present here a SimRoute that it's an academic software, it's an open source software that addresses the ship weather routing. In the left-hand side, we can see a panel of 3 different snapshots of a route that connects Barcelona and La Spezia. And if you pay attention, there are 2 routes, the minimum distance route that is plotted in black and the optimal route that is plotted in purple or in magenta. The background color is the ocean wave conditions, and we can see how the optimum routes, try to avoid the optimum route provided by the software, try to avoid the high energetic conditions because to be more efficient in terms of air emissions, in terms of sailing time, etc. So to define or to design a ship weather routing, what we need, which are the components that we need to design a proper software. First of all, a pathfinding algorithm. So it's a typical pathfinding algorithm to when we have different options to select that the most suitable option, then obviously the ship routing planet at departure and arrival port, the ship characteristics, and that will be related about the weather effects. The weather effects on navigation, it's important because and when we increase, for instance, the wave conditions, there is a penalization of the ship velocity. And also happens if we consider other meteoceanographic variables, such as the water currents, the wind, or even the ice. So to develop a ship weather routing, we need a meteoceanographic information that it may be hindcasting or forecasting in function of the exercise that we want to address. And also we need that information in a gridded system. Here I will present the different Copernicus Marine Services products that we have used to develop this system. The sim route requires, first of all, a grid and also a pathfinding algorithm. In the right-hand side, there is an example of the potential nodal connections possibilities. As we increase that, also we can increase the possibilities in function of the accuracy of the routes that we want to provide and we want to compute. So if we choose the red possibilities, so in the bottom and the left-hand side of the panel, we will realize that we need an additional grid refinement from the Copernicus products because they don't have enough resolutions to provide a suitable optimum route. Also, we need a pathfinding algorithm. In that case, the algorithm that we selected, the A-star. Probably we're familiar with the Dijkstra algorithm, that the Dijkstra algorithm is a greedy algorithm that it's not very efficient, and we need an algorithm that would be a little bit more efficient than the Dijkstra, and for that reason we select the A-star. The A-star is use an heuristic component that is the distance from the position of the ship to its final destination. So in the figure, the blue points, we can see how it's the open-end nodes that has been used by the algorithm. The A-star consider less open-end nodes, so it's much more efficient from a computational point of view. What else? To develop a ship weather routing or the same route, we need also to consider the wave effect on navigation. In that case, I show you one of the multiple formulations that are included in the SimRoute software. That is the formulation of Bowditch of 2002. And the formula is very simple. We have the final velocity is equal to the velocity of design minus a penalization that is provided by the F, that it's in function of the ship wave relative direction, and that it's also in the time function of it, we are talking about the following overhead seas, multiplied by the square of significant wave height. Obviously, the square of the significant wave height and also the computational of the ship wave relative direction are obtained from the Copernicus Marine Service. At the same time, there is additional formulations that we can get in the literature, and they are included in the SimRoute system, like Arsen and Koklov. So the products that we use or that it's considered in the SimRoute system are all of them. So all the European or all the products that involve the European boundary seas, like the Black Sea, Mediterranean, EV, the Baltic Sea, etc. Also, the software provider also includes the global product. And in the references that you will see in the last of my presentation, or here that's Grifoll 2022, you will see which is the products that we are considering in the software that to summarize, it's all the wave products that currently are available in the Copernicus marine surface. So just to have a look of the results, in the left-hand side, we can see an animation about the optimal route that it's in magenta and the minimum distance route that it's in yellow. In the software, they provide us the optimal route that you can see that it sails the eastern shore of Sardinia Islands. Meanwhile, the minimum distance route, it sails the western part of Sardinia, the western shore of Sardinia Island. So what does it mean? That if we compute the different variables obtained by the model, the significant wave height, it's larger in the minimum distance route in comparison to the optimized route. That is something that we expect according to the figures. The background colors in the left-hand side, it's the significant wave height. The sailing time is quite similar. The sailing time is reduced when we use the optimum, when we consider the optimized route, a reduction of 18%. The distance is more or less the same. Obviously, it's a little bit less in the minimum distance route. And finally, if we compute the emissions in the bold routes, we can see how for the optimized route, there is a reduction of the 15%. That result has been done using the Siemens products. Well, there is two additional modules. First, in the left-hand side, the results, it's estimation of the ship assessment in function of the optimum and the minimum route. The optimum route is again in magenta, and the minimum distance route is in yellow, and we can see how there is that reduction using the formulation of STEAM2 that's provided by Jalkan in 2016. And in all the cases, in CO2, in the NOx and SO2, and also the particle matter, the tones provided by the voyages in the optimized route, it's less in comparison to the minimum distance route. Also, there are one additional module that is the safety on navigation, and the sim route is able to compute that conditions that they provide that can endanger the ship, that it's the surf-riding and the parametric rolling. They are computed according to AMU recommendation. The parametric roller, it's when there is a encounter period, when the encounter period of the wave and the ship course, it's similar to the natural period of the ship oscillation. That it may be a problem that can lead to parametric rolling. And also the surf-riding occurs when the following sea conditions that then may accelerate the ship, and also it may produce a capsizing, so also maybe endanger the course. And the sim route identifies these spots of the potential parametric rolling or also surf riding. So where we can get the software, it's an open source code that you can get from my personal GitHub address. It's coded in Python, and also you can download the test cases so that all the scripts are ready just to run and to execute the scripts. Also, there is a under developing documentation, but I did some kind of fast start guides that may help just to run the test cases, just following 3 or 4 instructions. And also this code, it's used for several users around the world. And if you have any question, please don't hesitate to contact me in my email address. So the structure of the sim route, it's you will find a params.py, that is the file where you only have to include the different the input information that is related with the ship characteristics, also the product that you want to use, etc. And then the code, it runs following 3 different steps. The steps that you download using the appropriate libraries, the products from the Copernicus Marine Service. Then, because if you remember from the grid refinement that it's required to provide an accurate solutions on the optimal route, there is an interpolation in the step 2, and the step 3 finally it's the sim route computational itself that produce the results in a ASCII files in terms of a short report, and also in the NPZ file you have all the plots that are produced by the software. Is also there are some post-processing tools. For instance, the post-processing plot scripts using the Cartopy library in Python, and also 2 additional modules that I mentioned before related to ship emissions assessment and also safety restrictions. Well, just some final remarks. The optimal route, thing that may differ significantly from the minimum distance route. We have identified a 20% in time reduction. So that has an impact on ship emissions. For instance, in some cases, it may be raised to 34%. Also, the economical impact, it's relevant thanks to the cost, basically to the fuel cost savings. And also the benefit, it's not only in function of the wave storm, but also in function of the shape. Obviously, if there is a calm period, the minimum distance route and the optimal route, it would be the same. So that it's thanks to the new generation of high-resolution meteoceanographic forecast services provided by Copernicus Marine Service, and also the inclusion on efficient algorithms, and also currently is used as a teaching tool that, especially for the safety on navigation, that it's a software that has been used for several universities and maritime academics to explain some lessons related to safety on navigations mainly. And the future works that we are working on that, it's the wind and currents effect that are still not considered. However, it's an open source, so I invite you to include them if you think that it's that you like, and also to implement a multi-objective algorithms that you can consider the travel quality, safety restrictions, etc. And we think that this software, this kind of products will be necessary in the new generation of unmanned ship implementation. Just finally to mention the SimRoute work team that myself and also 2 professors from the Universitat Politècnica de Catalunya, Marcela Castells and Clara Boren. And I include here some references about that we explain the methodology and also application of the software. And if you and you have any question, I will try to reply. Thank you so much.
Thanks a lot, Manel, for your nice presentation. And yeah, we have plenty of questions for you, so we will go to that now.
Okay.
So the first question being, when you say optimized route, which parameters are you minimizing or maximizing?
The parameter is the sailing time.
Okay, thanks a lot. Okay, so we have also 2 questions, almost the same question. Is the optimized route calculated only before departure, or is the route optimizations happen in real time as well as the ship moves?
No, now it's just only calculated before the departure, because it's when we assume that we have the forecasting products from Copernicus Marine Service.
Okay,
But,
thanks.
however, when you have sailed in a specific period of time, then you can recompute again you can use again the software, the sim route.
Okay, thanks. Good to know. So 2 are good. Okay, can no sail zones be defined, EU Natura 2000 areas, safety zones around offshore platforms, etc., to calculate optimal routes avoiding those areas?
Yes, we have done that, not because Natura 2000 or offshore platform. We have to do that by the ice information that when the ice coverage exceeds a specific thickness, then we exclude from the computation. But it's very easy because the only thing that you have to do is from the grid refinement computed by the software, then you can exclude those points that you think that are not navigable.
Okay, good to know. Thanks. Okay. The measures of CO2 reduction and fuel consuming were calculated numerically or measured in a control experiment.
Well, thanks. It's a good question. The CO2 reduction estimation is done by a method that estimates the CO2 in function of the engine reports. So it's not, they are validated and verified in some cases and for particular conditions of ships. And it's the method that I mentioned before, it's the STEAM2. But in any case, in that estimation. So it's quite difficult to compute the emissions. It's not easy because you need a complete track of the ship, a complete monitoring of the ship variables. However, the STEAM2 has been proved that it's a suitable method to obtain a first estimation of the CO2.
Okay, thanks for the explanation.
There is the reference of Jarkan in 2016 that may provide you more information about these exercises.
Okay. Yeah, we put the link of your paper in the chat and it's also available on the website so people can look into it for more detail. Thanks.
Okay.
Sorry. Okay, next question. Were you able to account for extreme weather events in your algorithm?
That it's the only things that you have to do is to select those events that you are interested to simulate. For instance, if there is an special, for instance, in the Mediterranean, the Gloria storm that occurs 3-4 years ago. So you can select the data for this period and include that in the SimRoute software.
Okay, good to know also. And yes, so almost the same question. How well this algorithm performs under severe ice conditions? Have you tested it in the Arctic region?
Yes, we did in the Arctic region. However, in the Arctic region, it's a little bit tricky because there are, in function of the thickness of the ice, there are some ships that they can navigate or they cannot navigate. So it's something that still we are working on that because the effect of the ice on navigation, it's not as universal that happens, for instance, in other variables, for instance, the water current or the wave that has a clear penalizing effect that it's more or less estimated by the formulations that I mentioned before.
Okay, thanks. And yeah, so one more question. Was there any particular reason why you picked the example route of Tunis to Nice? How did it compare to other tested routes?
Well, in the web page, there are one example per each one of the products that Copernicus Marine Service provides. So there is one example for the Baltic Sea. There is one example for the Mediterranean Sea, etc. And I select the Tunis and Nice connection because it's quite spectacular, because the difference between to be in the minimum distance route or to be in the optimized route, it's that you are sailing in one side of the island or in the other side of the island. It's the only reason, because it's quite illustrative example. But in the GitHub there are more examples.
Okay, thanks a lot. Okay, next question, sorry. Can the suspended particulate matter be captured through SimRoute?
Well, I'm not sure about these questions. When I said particulate matter, it's one of the results that is provided by the emissions assessment module.
Okay, thanks. Another question about the methodology. Have you compared the data with actual data from ships, and how different are they?
Yes, it's quite different, because one of the considerations that here we compare with the minimum distance route, but currently not all the ships are following the minimum distance route. So the effect or the impact to optimize the route comparing with the data from ships, that it's data that we call AIS data, automatic identification system, that each ship of the big ships they must have a systematic position, a georeferenced position. When we compare this data with the optimized route that we have that the sim route provides, still the differences it's larger than the minimum distance route, because not many of the ships used to follow the minimum distance route.
Okay, thanks a lot. Okay, now we have two questions about physical phenomenon. Have you checked the role of edges or their effect on the optimization? And almost the same, are you including effect of internal waves?
No, because currently the only phenomena that it's included in the sim route, it's only the wave, because the wave we have tested before that it's the most relevant meteoceanographic variable that penalize the ship navigation. And second term, there is the wind in function of the ship, because for instance, the container ship has a strong, because they are for the height, they have a strong effect because the wind and also the ice in some cases. But the effect of the water currents, it's a minor issue according to our preliminary test.
Okay, well, thanks a lot. I
You're
think
welcome.
that was the last questions about your presentation. Yeah, so this one is good also. So yeah, thanks again, Manel, for your presentation. You have lots of kudos in the chat for the participant. So thanks again for joining.
Thank you. Thank you to invite me, and has been a pleasure from my side. Thank you so much.
And yes, so now I welcome the last guest speakers of today. So Achille Ciappa from Italy. So welcome, Achille. I can see your camera right now, but
I don't know if can you hear me?
yeah, I can hear you, but I can see you for now.
Because my video has been disabled by the
Okay, so I will put. Okay.
Okay, anyway, I can
Yeah, it's
go on with my presentation. Okay.
Yeah.
So I am Achille Ciappa. I am a satellite oceanographer. I worked for years, and now I am. Okay, so I probably start my video. Okay, hello to everybody. So next slide. I'm trying with my keyboard, but I am not able.
Yeah, you can click on the screen and then it will be able to move.
Okay.
Yes.
Okay, so I wish to illustrate what is oil trajectory analysis. I promise I will use the acronym OTA just here. There will be a brief explanation of what is oil trajectory analysis. The provided information results in Mediterranean Sea and how can be used. So oil trajectory analysis, it's a data set of oil spill trajectories lasting 10 days in coastal areas, produced for 5 years. For 5 years, because the purpose of this data set is to provide significant statistics on the oil transport. Trajectories are simulated backward in time, which is a little bit unusual. So there will be a couple of slides that will illustrate this technique. So what is backward in time integration or reverse modeling? Now on the left is shown how an oil spill, a conventional oil spill works, oil spill model works. So we have an oil spill offshore. and then the oil is moved forward in time up to the destination. Instead, on the right side, you can see the concept of backward in time integration. We start from a receptor point that is the red dot on the coast, and we go backward in time. We track the oil trajectories to possible sources. So you see below the two, it's the same equation, but it's integrated forward in time on the left and backward on the right. Now, this concept of backward in time integration, it's an old concept. This was probably for the first time was implemented in a pioneer oil spill model that was used by NOAA. It was the Sardus Material Group in Seattle of NOAA, which developed this concept. And this group is famous because they worked on the famous Exxon Valdez oil spill in Alaska. Why this concept of reverse modeling or backward in time has not been used for 40 years? It's because this concept is very requiring in terms of the data needed. The needed data are sea currents and winds. But while the winds data were more or less available in the past years provided by meteorological organization, the problem was with the sea currents. So this is the reason why this concept of reverse modeling can be applied today, because we have a huge data set of sea currents as a sample provided by the Copernicus marine service. So in this application of the Mediterranean Sea, I've been used sea surface current from this two data set. And the technique of reverse modeling has been applied for each one of these red dots on the coast of the Mediterranean Sea. And this is an example of application. In the figure A, you can see 5 oil trajectory starting on 20 of July from a receptor point on the Algerian coast. And these are tracked backward in time from 20 July to 10 of July. All these 5 trajectories start at the same time, probably it's midnight, are tracked backward. And in the figure B, you see all the trajectories tracked for 5 months of July from 2015 to 2019. The trajectory have been released every 30 minutes from, in this case, from point A. And in figure C, you can see the trajectories starting from point A and point B. And the common area is plotted in dark red. But the sense of the common area is that an oil spill occurring there probably will reach the coast in points A and B. So now this work has been done for all the black dots on the coast in figure A. So it was a huge number of simulated trajectories, because trajectories start every 30 minutes from each one of the about 3,000 points all along the Mediterranean coast. So the important thing of the oil trajectory analysis is that this database establishes a link between the coastal sites and the sea cells. This trajectory have been reported over a regular grid of the sea, sites at about 4 kilometers. So the information provided is that in any point of the sea, as pointed G in figure A, we have the total number of trajectory crossing the sea cell. Where do they come from? From the points on the coast. How many trajectory come from each point on the coast and the relative runoff times. So in figure D, you can see the influence area of oil spill that will beach in point S5. So we have a sort of climatological picture of the oil transport for each one of the points of the coast. This is another example of the information which is provided. This is for a group of points, as could be a marine protected area. So again, in figure D, we have the influence area from where the oil spill are expected. Please note that these figures are done, or the data set is organized on a monthly basis. So we have these maps for each month. And we have, so the influence area in figure D, average travel time, minimum travel time. So this picture are refer to receptor points on the northern coast of Crete. In summer, as shown later, most of the oil transport comes from north, from meteoceanographic reasons. So now, in this picture are reported the main oil tanker routes, they crossing the Mediterranean Sea, and the marine protected area, which are colored with different colors in different areas. I will briefly show you these 5 examples that probably are the most critical cases from A1 to A5. This is the Spanish coast, and you can see the difference between summer in August and in December. The probability that is shown in figure B and C is the pitching probability for an oil spill. And so in light green is shown the probability higher than 5%. And you can see the difference. This is the area Spanish coast from Cartagena to Alicante is probably critical because we have the oil tanker routes, and in this area, the oil, from the climatological point of view, in this case, probably are winds that will push the oil quickly towards the coast. In winter, in figure C, the situation is different. Probably the most critical area are west of the Ibiza and Palma. These are the maps of the North Mediterranean. North Mediterranean is particularly critical because in figure A, you can see in blue is plotted the Pelagos Sanctuary, which is a protected area for marine mammals, and you can see how many oil tanker routes cross this area. And probably the most critical situation is in January, northeast of Corsica, and in summer, in figure C, it's along the Italian coast here, Genoa and Spezia. At the bottom is shown the Sicily Channel, and it's interesting to note in summer, in July, the island of Malta or Pantelleria, there is a huge probability that the oil spill can reach the northwestern part of this island. This is mainly due to the strong and stable currents in the Sicily Channel. It's are well studied current system like the Atlantic Ionian Stream, which sort of that reach the northwest of this island is high. This is another example. In the Aegean Sea, as example, in summer, you can see the effect of the Meltemi wind. It's a Meltemi wind. It's a northern wind, almost constant in summer in this area, and so the oil should reach the northern coast of the island here. And you can see in figure A how many oil trucks, oil routes cross the Aegean Sea, which are directed to the Black Sea at north or to southeast to the Suez Channel. Around Cyprus or on the eastern tip of the Mediterranean Sea, also in summer, the oil transport is very energetic. Okay, so now these are the last slides, and how this information provided by oil trajectory analysis can be used. Now, this picture, I put this slide because this is a SAR Sentinel-1 SAR, synthetic aperture radar image, showing an oil spill occurred north of Corsica. Probably you can also see the ship causing this oil spill. That is the white dot here on the eastern south border of the oil spill. So, I wish to say that SAR satellite images are a very efficient tool to detect oil spill. However, the and also the SAR images are provided by are currently provided by many operational satellite constellations. It's Copernicus, Sentinel-1, Terra-Sarixi, Cosmos Skynet. These are European. COMS-5 is Korean. RadarSat is Canadian. So we have a lot of SAR satellite constellation. But if we detect an oil spill like this, oil trajectory analysis is not the best tool to predict the beaching sites. I can explain this better. If we have an oil spot like this, we have the beaching site provided by oil trajectory analysis, but it's much better to run a conventional oil spill model because this is driven by wind and current data of the following days, which provides much more reliable forecast than the beaching sites provided by statistical analysis of the. So, which is the purpose of oil trajectory analysis? It should be the next slide. Okay, oh, sorry. Okay, so oil trajectory analysis should be used for planning satellite surveillance. Now, satellite surveillance is done by the CleanSeaNet service of the European Maritime Safety Agency, but the monitor areas are where oil spill most frequently occurred in the past, and the sea area requested from each single state. Should be also included the sea areas where oil spill quickly and massively can reach. So this is now this information is available and could be used for this purpose. Also, this image shows how many satellite images can be available. These are only the satellite images available from the Cosmos Skymet satellites, but we also have Sentinel-1 and Terra-X, so we have a lot of satellite images. So the problem, and also this number will be growing because we have many private operators that are introducing into the satellite market, which also provide provide images acquired by small satellite SAR sensors. So we have the necessity to introduce priority criteria in satellite surveillance. Now in this picture, I try to select some probably the most useful images. So this is another station that suggest or a possibility the results of oil trajectory analysis. So this is okay. Thank you for your attention, and I am happy to give answers.
Thanks a lot, Achille, for your nice presentation. And yeah, it was really interesting, and we have a few questions for you, so we will go to that now, and I will read them. The first question being, in addition to tracking the oil trajectory, are the positions of the oil drills, the height of the drilling machines, and impact of sea currents also monitored?
I have to understand what position the oil drills, the height of the drilling machine impactors. Yeah, but the answer could be yes, because the starting point of the oil trajectory analysis is sort of climatology on transport. So it does not matter much how the oil spill can be generated by obviously the impact of the sea currents is the crucial point of this analysis. The climatology of the oil transport is built basing on winds and sea currents. So this last point of the question is the answer is yes.
Okay, thanks. Okay. Next question, is the algorithm able to track any kind of oil spill? I mean, irrespective of the type of spillage? I don't know how to pronounce this word, sorry.
I don't know what is higher of spillage.
I think maybe it's a typo mistake, like type.
The type of oil.
Yeah, I understand like that, yeah. I'm not sure.
Okay, so I missed during the presentation, I missed to talk about the weathering effects in oil spill modeling, because it depends on the type of oil. So, as a sample, heavy fuel, since heavy fuel for many, just a little bit part of the heavy fuels disappear or evaporates. And as a sample, diesel, most of diesel vanishes. But when we purpose of this work is to understand if the oil can hit some coastal sites. So if the oil, most of the oil evaporates, good. It means that the oil spill occurred that will not hit, or in a small part will hit the coastal site. But it's a sort of we don't know exactly in the future which oil spill will hit a specific coastal site. So I would answer to this question saying that it's it's a preventive action. So we can expect worst as usual.
Okay, okay, thanks. Thanks for trying. Okay, a more open question about the use of your model. Can the oil trajectory analysis model be used to search for aircraft debris in the event of a plane crash at sea?
Well, we this application for oil spill, we have a motion equation of the oil. So the concept is probably the same, but the application need specific
Yeah.
evaluation of the. Yeah.
Okay, thanks. Okay, next question. How long after an oil spill happened can it be detected in openly available ocean data apart from SAR data? Which parameters does it influence?
AR, radar data are the best tool. Obviously, satellites provide monitoring of large area. So this is the reason. Also, SAR data satellites are not affected by clouds, are not obscured by clouds. So this is another reason. There are other oil spill can be detected also by other satellite data, but I can say that the main tool is our satellite, and SAR data are surely the best. Now, without entering in details on satellite detection of a spill, which parameters does it influence? Oh, obviously, danger.
Okay, thanks a lot. Okay, another question about the presentation. In the figures, there were oil-shaped tracks. Could you explain what they are? Is it an AIS with filters, or does it include all ships in that area?
Basically, in the AIS data, there are some fields that tells you which kind of ship is. There are some classes of ships, and so can be selected by the AIS data. Anyway, the tracks, the oil tanker tracks in the Mediterranean can be found in many papers, published papers, or almost known because we know the ports or the passages through the straits. So it's a consolidated information.
Okay, thanks a lot. Another question about the model. Do you also account for the Stokes drift and tidal currents?
These effects should be included in the sea currents data that are used in the simulation. So the marine service, Copernicus Marine Service data accessed are produced by models. So this is surely they include the Stokes drift and tidal currents.
Thanks a lot. Okay, one question. How does this tracking differ from the oil spilling advisories used in operational services like that by the Indian National Center for Ocean Information Services?
I don't know. I never tested this system. So I don't know if they have modules to perform a reverse modeling application. So I don't know. I collaborated with Indian scientists in the past for the tar pollution on the west coast of India, but it was something like 8 years ago. So I suppose that 8 years ago.
Okay, thanks. Okay, so we have time for 2 more questions. Okay, so do you use a specific model to consider specific oil characteristic, or is it a language drift model that is used? We can't hear you very well.
Oh, sorry.
Okay.
Okay,
Oh.
oh, sorry.
No, it's okay,
No.
we can hear you now.
Okay. The oil characteristics are not considered in reverse modeling because it's preventive work done before an oil spill occurs. So we do not know which will be the next oil spill. Will it be a strong, fastly evaporating oil? We don't know. So it's for this reason it's not considered. In this type of oil is not considered. Also because if most of the oil evaporates anyway, cracks or little fraction of the oil anyway will reach the coast. So the answer is, from technical point of view, it's Lagrangian risk model that is used.
Okay, thanks a lot. And we have time for 1 more question. So the last one being, the tracking of the oil is more today-like due to buoyancy, so winds and surface are dominant. What will depth, 3D, and modeling add to the models?
Yeah. In my opinion, the best use of this oil trajectory analysis is for to understand from where oil spills are dangerous. So this is the classic question at the beginning of this study. So the tracking is bidimensional. It's surface tracking, and the purpose is to understand which sea areas must be monitored first for a specific coastal site or a marine protected area. So this is the purpose, the basic question, and the application of this study.
Okay. Okay, well, thanks a lot for your answer, Achille. And yeah, thanks again for your participation. It was really nice to have you, and thanks again. And yeah, so now for the participant, we are reaching the end of today's session. So I hope this was an insightful session, and thanks again to all of our speakers for their great presentation. And yeah, we have a few unanswered questions also, but we will provide a post-event report that we will make available during the following day. So no worries if your question hasn't been answered. And yeah, before you leave, a few points, sorry. So the practical session will be the day after tomorrow. If you haven't had time yet, I invite you to take the full tutorials to get ready for it. The tutorials are already available, but the video tutorials will be made available in a few hours. So no worries if you can't find it. It's normal. It will be available with the replays and the presentation of today. And these tutorials are available in full on the event website. And there is a tab at the top where you can find the Jupyter, QGIS, and R section, all of them using Siemens data. And finally, I just want to remind you that there is a section on the website next to the Q&A reserved to the poll. We would really like to have your feedback on today and what we could provide in the future. So if you can please take 2 minutes of your time, that would be really helpful. And yeah, so you will receive an email in a few hours when the replays and the full tutorials will be available. And we hope to see you in today's time. Bye-bye.